Now suppose we take x is equal to 1 now, because till now what we have taken any x between, because whenever we are defining a function on the domain is R, you have to define the function for minus infinity to plus infinity any value. So here you can see that we have first we consider x is between minus infinity and 0. Why you are considering like that? Because there is kind of simplicity, there is some kind of pattern of this function. So minus infinity to 0, this function is actually 0. So that is why we find it. Whenever x is between 0 to 1, x is greater than equal to 0, less than 1, then this function of this value is constant, it is 1 by 8. Now we will take greater than equal to 1. So equal to 1, whenever x is equal to 1, then we want to find f of x, f of 1, f of x1 we want to find. This is nothing but probably that x less than equal to 1. So for this we have to first find x, what is x less than equal to 1. So x is less than equal to 1 is nothing but all s belongs to this s1 such that x of s less than equal to 1. Now what are, because just remember that Rx is range of this random variable 0, 1, 2 and 3, and those things, so x of number of head actually nothing but 3, x of head tail nothing but 2, like this, x of tail head it is nothing but 1, x of tail it is nothing but 0. So this is the definition of the random variable. So now it is less than equal to 1. So we are considering all the value taking less than equal to 1. So that means this random variable can take value 1 or it can take value 0. Only two value it can it satisfying this inequality. So 0 and 1. So what are those values it can take? 0. 0 is nothing but t. So then 1 corresponds to only one head. So this is nothing but tail head, then tail head tail, then head tail. So these are the 4 values it can satisfy this relation. So there are 4 equally likely. So then what is the probability now? So then x less than equal to 1 is nothing but probability of this event. So this event contains 4 points, and so I think this is fine. So out of 8 possible way, 4 equally likely. So this is nothing but 1 by 2. Hence this probability will be 1 by 2. So not only that, if you consider x is any value greater than 1, suppose it is 1.8 or 1.5 on any value. So x is belongs to, suppose greater than equal to 1, less than, sorry, 1 minute, yeah, x is greater than equal to 1, less than 2, any value you take, x is 1.8 suppose. Then what is f of x 1.8? So what is f of x 1.8? So this is nothing but probability that x less than equal to 1.8. So then we have to find what is this set x less than equal to 1.8. So this is nothing but all s belongs to s1 satisfying the relationship x of s is less than equal to 1.8. So now what are the values it satisfying this relation? So it can less than equal to 1.8 because it is taking the only integer value 0, 1, 2, 3, 4. So here you can see that because it can take only 0 and 1 satisfying this relationship. So 0 means t and 1 means t head tail t, tail head and head tail. So these are the 4 values. So that is why probability of x less than equal to 1.8 is nothing but again 4 by 8, 1 by 2. So this is constant in this interval. So that is why f of x it is equal to 1 by 2 for whenever x is greater than equal to 1, less than 2. So that is what we found here in this. So similarly you can show that whenever x is in this interval, suppose x is better than equal to 2, less than 3. So you take any value. So inside the interval, suppose x is nothing but 2.3. So in this interval, so then what will be the value f of x 2.3? So this is nothing but probability that x less than equal to 2.3. So now we have to find what is this set. So x less than equal to 2.3 means this is nothing but all s belongs to s1 such that x of s less than equal to 2.3. So what are those value it is satisfying? Because this random variable take the value 0, 1, 2, 3. So 0, 1 and 2 all actually belongs to this set. So 0 means 0 head t, 1 means one head, head, tail, 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 head, tail, and tail, tail, head, and then basically see, you can see that whatever the previous observation, here we are adding more observation. That's why it is called the cumulative distribution function. So cumulatively we are so it is, we are adding sequentially. So now then we have to consider the 2 head also, because it is satisfying x is equal to 2, also it is less than equal to 2.3. So 2 head will be nothing but head, head, tail, then tail, head, head, then head, tail, head. So tail, head, head. So tail, tail, head. So then 1, 2, 3, 4, 5, 6, 7. 7 points are equally likely points. Hence, f of x 2.3 is nothing but 2.3 is nothing but probability that x less than equal to 2.3. So here 7 points are there. So that's why equally likely points 7 by total possible way it can come 8. Out of that 7 that it can come 7 by 8. So that's why this probability is 7 by 8. So we consider any point here. So that's why for any x belongs to, or we can just mention it, for x whenever x is greater than equal to 2 less than 3. So then f of x nothing but, because any point we took that, it is nothing but 7 by 8. So now the another because only 0, 1, 2 and 3 also we have to consider. So what is the, whenever x is greater than equal to 3 less than infinity, any value between this interval, because now we understand the pattern. So then the remaining interval only this interval. So let us consider x is equal to some 4. So then what is or 4.5, any number which is satisfying this. So then what will be the f of x 4.5? So f of x 4.5 will be probability that x less than equal to 4.5. So now we have to first find what is denoted by x less than equal to 4.5. It is the event. So all s belongs to S1 such that x of s less than equal to 4.5. Now x is the range is 0, 1, 2, 3. So that's why all actually s satisfying this relationship, so that it is nothing but whole set S1, because it contains all the point, all the those are here, and not only that, the additional head also 3x is equal to 3 also it will come. So because it contains, so basically head all points are there. So that's why then what will be the probability that x is less than equal to 0.5. So let us write in the next page. So f of x 4.5. So f of x 4.5. f of x 4.5 means probability that x is less than equal to 4.5. So then because it contains all the point, so 8 possible way by, actually it is a certain event, it is equal to 1. So we consider it is a 1 point in this interval, x is greater. So hence for x greater than equal to 3 less than infinity, f of x is nothing but 1. So then we can write down the function by summarize. So summarize these things. So basically you can see that, so f of x is we have started from here. So here see that it is 0 whenever it is inside this interval. So f of x is equal to 0 whenever x is less than 0, greater than minus infinity. Then what is the value? Then next this value is nothing but whenever x is between 1 and 2. So then 0 to 1. So whenever x is between 0 to 1. So here actually this is the I think this is here. So x is between 0 to 1, then in that case this value is 1 by 8. So then x is between greater than equal to 0 less than 1, this is nothing but 1 by 8. So then x is greater than equal to 1 less than 2. So then this value is, here it is mentioned, whenever x is, so then this value is equal to 1 by 2, 1 by 2. Then whenever x is greater than equal to 2 less than 3, so then here we have considered, so this value is 7 by 8. So this is nothing but 7 by 8. So then whenever x is here just we have shown it greater than 3 less than infinity. So then this value is equal to 1. So, then we found the cumulative distribution function associated with this random variable. So, now we just want to show graphically represent this function graphically. Suppose this is 0, then 1, this is 2, 3, 4, 5 like this, minus 1, minus 2 like this. So, now just I want to make this is suppose 1 by 4, this is 2 by 4, 1 by 2, this is 3 by 4, this is 4 by 4, 1 minute, I just did the mistake, okay, 1 minute. Just I want to divide it, okay. So, this is I just want to 7 by 1 by, sorry. So, this is nothing but, so this is nothing but 1 by 8, this is nothing but 2 by 8, 3 by 8, this is 4 by 8 means 1 by 2, this is 5 by 8, 6 by 8, 7 by 8, this is 1, this is the 1. So, then just, so now because of function we want to, so this is f x x we want to find, at up to x this function is 0 only, this is 0, at 0 this is nothing but, what is the value, 1 by 8, at 0 it is nothing but 1 by 8, at 1 this become 1 by 2, at 1 it is become 1 by 2, up to 2 it is there, then at 2 this become 7 by 8. So, this is nothing but 7 by 8. So, this is, then at 3 this is nothing but 1. So, this function is nothing but 1. So, you can see that it has left discontinuity. So, basically if you take at 0 f x 0 minus, so this is nothing but limit suppose f of x x minus h goes to 0. So, because it is sorry, this is 0 minus h goes to 0. So, if you take the left limit, this is nothing but 0, but at 0 f x of 0 this is nothing but 1 by 8. So, which is not equal to f x of 0 minus. So, similarly you can show that f x of 1 minus is actually 1 by 8, which is not equal to 1 by 2, which is actually f x of 1. So, at every point where there is a probability, it has some left discontinuity, but it is not it is right continuous always. So, some of the properties of the cumulative distribution function we will know now. So, this is the cumulative distribution function. I hope you have understood it. Some of the properties, like because it is a probability, it will be always between 0 to 1, and we can show that whenever it is a non-decreasing function. So, you can see here also it may be constant, but it will always increase, it will not decrease. So, non-decreasing function, it is easy to prove. So, so what is the property? So, if x1 is less than x2, two real number, then f of x x1 is less than equal to f of x x2. So, in general we can prove. So, because what is x f of x1, f x of x1 is nothing but probability of less x less than equal to x1. So, what is f of x x2? F of x x2 is nothing but probability that x less than equal to x2. So, first we will find out what is the event correspond to that. X less than equal to x1 is nothing but this event is nothing but all s belongs to the sample space such that x of s is less than equal to x1, and x less than equal to x2, what is this event? So, this event is nothing but all s belongs to s such that x of s is less than equal to x2. Now, if x1 is less than x2, then you can see that all x s we are satisfying this. So, if and then s belongs to this set s belongs to s such that satisfying this relation x is less than equal to x1 implies xs will be less than equal to x2 because x1 is less than x2. So, all s belongs to hence all s belongs to this set x less than equal to x1, that means this set implies that s belongs to if s belongs to this set, then s belongs to x less than equal to x2, because this set, this is also satisfying because x1 is less than x2. If this satisfy this relation, so then this must satisfy this relation also. So, which implies this set actually subset of this set, and we have already proved that if A is subset of B, then probability of A is less than equal to probability of B. So, which implies probability that x less than equal to x1 less than equal to probability of x less than equal to x2. So, which implies f of x x1 is less than equal to f of x x2. So, that is why it is a non-decreasing function. So, that this example also it shows that it is a non-decreasing function. Now, f of x goes to infinitive, f of x this is equal to 1. So, just we will not prove just we will give some kind of intuition how it can be proved. So, basically x is a actually x is a random variable, it is a measurable function s to r, basically it is taking for all values r. Now, what is f of xx? F of xx is that probability that x less than equal to x. So, x less than equal to x, we have just denote that all this, okay, x less than equal to x, this is nothing but all s belongs to s such that xx less than equal to x. Now, if you take limit h x goes to infinitive, then limit, if you consider this set, what will be this set? Limit x goes to infinitive, this set will be all the limit will take limit x goes to infinitive, all s belongs to s such that xs less than equal to x. Now, if you consider x less than equal to infinity, because x is actually nothing but a function from s to r, it will satisfy, it will be nothing but after whenever x will be very large, x goes to infinitive, it will satisfy all s by the all s. So, that is the intuition here. So, it become the certain even s. So, in that case limit x goes to infinity, probability of x less than equal to x, this is nothing but probability of s which is equal to 1. So, it is not a rigorous proof, it is just a intuition only why it will be 1. So, that is why this is nothing but, so this is actually coming from, so this is the limit x goes to infinity f of xx. So, this is the probability of x equal to limit x goes to infinity, probability x is equal to x, it is nothing but the certain ever less. So, similar intuition it will work for this case also whenever x goes to minus infinitive. So, whenever x goes to minus infinitive, here limit x goes to minus infinitive x less than equal to x. Now, because range of x is a subset of a real number, so it is a real number always. So, limit x goes to infinitive minus infinitive, all s such that x is satisfying x less than equal to. So, x is always a real number. So, now if you x goes to minus infinity, it will be after some time. So, basically the intuition is that no s will satisfy x is less than equal to x whenever x is goes to minus infinity. So, it will be becoming a null set. So, in that case limit x goes to minus infinity, f of x will be probability of null set, this is equal to 0. But it is not the exact proof, we are not going through in details rigorously, it is just a intuition just we are providing here. So, how probability of x goes to infinity, f of x should be 1, and whenever x goes to minus infinity, f of x should be equal to 0. And also we have seen from the example that we are not going to prove all these details. So, it will be a right continuous, but it may be a left discontinuity, because we are providing we are taking this definition is f of x is like this. So, there may be possibility of left discontinuity, but it will be always right discontinuous, right continuous, always from the right it will be f of x a plus will be equal to f of x a for all a belongs to the real number. So, that will be right continuous. So, these are the some of the properties of the cumulative distribution function. So, in this case also we can see that it is always right continuous, but there may be some left side there may be some discontinuity. So, these are the some properties of the cumulative distribution function. So, here in this example find the distribution function and case the distribution function of x. So, that same example actually we discussed. So, it is the probability that so what are the values 0, 1, 2, 3, 4, and then these probabilities we have already computed at x equal to 0, 1 by 8. So, this is the step function we have also drawn in this example. So, here we have also shown that the same thing it is given here. So, that we completed the discussion of cumulative distribution function of a random variable x. Hope you have understood it, or you can go through again, or you can have some questions, then we can again discuss. So, now this most of the cases we discussed the random variable as a taking the only integer values. So, some of the finite integer values 0, 1, 2, 3, 4 like that. So, these are very simple to understand, that is why we discussed initially. But if you consider, we have already told that some of the random experiment the sample space may be infinite. So, it may be uncountable infinite. For example, if you consider lifetime of electronic goods. So, in that case the sample space will be 0 to infinity, and in that case how we will define the random variable, or how you will discuss the distribution function. So, that case we say that it is like a continuous, because you are taking a range of x is continuous. So, in that case we will discuss that how we can classify the random variable with respect to their some of the characteristics, whether characteristic of the distribution function, it may be continuous, it may be differentiable, or it may be not differentiable, or it may be looks like staircase function, or it may be step function, that is staircase function. So, based on the nature of the random variable, we can classify the random variable into two parts. One is called discrete random variable and another is called continuous random variable. So, in the next part we will discuss the different types of random variable, discrete random variable, continuous random variable, and how we can analyze the data with respect to discrete random variable, continuous random variable, how you can find the probabilities, that we will discuss in the next part. So, we have learned the distribution function, cumulative distribution function f of x corresponding to the a random variable, corresponding to a random variable associated with a random experiment. So, that we have already discussed here. Now, some example also we have discussed. Now, based on the if you can see the distribution function here. So, here this distribution function is not continuous, it has a left discontinuity here. So, that we have already checked that left discontinuity, and it looks like a staircase function. So, sometimes some of the examples will show that. So, this distribution functions may be continuous also, or range of the random variable. Here range of the random variable is nothing but only discrete 0, 1, 2, 3. Now, some of the random variable, suppose if you are considering a random variable, you are throwing a dart like a on a, there is a, suppose a there is a target, and you want to, so some giving some throwing this some dart here in the target, and this because we are not exactly accurate. So, that is why this is several places it is actually falling. So, now we just want to check that what is the distance from the center it is coming. So, distance. So, distance, if you take this distance, and then it will be this distance maybe if you are accurate exactly, then it may be 0, otherwise it may be 0 to some value. So, this value, suppose because this is the total radius r, suppose this is radius r. So, maximum value may be r, and then it will be any real number here. So, it is so that is why if you define the random variable is nothing but the distance from the center, it is actually this target is falling. So, then this distance actually it will be any real number. So, in that case it is a continuous, this random variable will be continuous. So, Based on this distribution function, we define this random variable is categorized, classified into one is called discrete random variable. So, discrete random variable and discrete random variable, and other random variable we say that continuous random variable. So, first we will discuss what is discrete random variable. So, discrete random variable is that whenever if you see the CDF function, cumulative distribution function, values taking changes values only in jumps. So, here in this example, so that is why we first discuss this example. This random this distribution function, you can see that it is actually constant up to 0, it is 0. At 0 the value changes. So, this is 1 by 8 and then it is constant again up to 1. Then from 1 this value is 1 by 2, it is constant again, and from then 2 it is again constant 7 by 8. So, it is like a staircase. So, that is why it is written like whenever this distribution function fx changes values in jumps, at most countable number of them. So, this range of random variable may be countable also. So, infinite also, but it will be countable infinite. Each constant between the jump, that is fx is a staircase function. Then x is called a discrete random variable. So, alternatively x is discrete random variable only if its range contains a finite or countably infinite number of points. So, infinite number of points it can take, but it may be countable, it has to be countably infinite number of points. So, here what we found that, so you can so in this example you can see that if you find this distribution function f of xx, this is actually it is equal to 0 whenever x is greater less than 0, greater than minus infinitive. It is nothing but 1 by 8 whenever x is less than equal to 0, greater than 1 minute. So, this is greater than equal to 0, x is greater than equal to 0, less than 1. It is 1 by 2 whenever x is greater than equal to 1, less than 2, and whenever it is 7 by 8 whenever x is greater than equal to 2, less than 3, it is equal to 1 whenever x is greater than equal to 3, less than infinity. This is the distribution function. Okay. So, basically you can see that this function changes at a jump at some of the points. So, basically if you compute suppose f of what is f of 0 minus, f of 0 minus is nothing but 0. So, but this is not equal to f of x 0, f of x 0 is nothing but equal to 1 by 8, which is 1 by 8. Now, what is the difference? F of x 0 minus f of x 0 minus, what is this difference? So, this difference is nothing but 1 by 8. So, similarly we can find what is the difference. This is the jump actually, this is f of x 1 minus f of x 1 minus. So, f of x 1 is nothing but at x equal to 1 if you put, it is 1 by 2, f of x 1 by x 1 minus is nothing but 1 by 2 minus f of x 1 minus is nothing but 1 by 8. So, this is nothing but, so how it is coming? So, if you take the limit h goes to 0, f of x 1 minus of h. So, h is positive number 10 to 0, 1 minus h. So, 1 minus h whenever it is a negative number less than 1 number, this value is always 1 by 8. So, that is why if you take the limit, it is nothing but 1 by 8. So, there is 1 by 8 coming. So, then what is this difference? So, this is nothing but 4 by 8. So, this is nothing but 3 by 8. So, similarly you can see that f of x 2 minus f of x 2 minus. So, this is left limit f of x 2 minus f of x 2. So, this is nothing but f of x 2 is 7 by 8 minus f of x 2 minus is 1 by 2. So, this is 4 by 8, 1 by 2. So, this is nothing but again 3 by 8, no sorry, This is again 3 by 8. So, now what is f of x, the 3 minus f of x 3 minus, so this is nothing but this is 1 minus this is 7 by 8. So, this is nothing but 1 by 8. So, now just we want to know what are those values actually. This is the jump actually. This is nothing but here when we draw. So, basically this is the jump here, this is 1 by 8, this is 3 by 8, this is 3 by 8 and this is nothing but again 1 by 8. So, these are the values. Now, we want to find what are the probabilities actually at that point, because see that this jump occurring in that where this range it is taking the values, range is 0, 1 to 3.